This particular assignment was given to me by Saiket, the Saiket system, in the course of my internship, and it demands that I analyze the data as customer churn data set. Yeah, what they gave me actually was telco. This is the data set, telco customer churn data set. That's what they gave me. So this data I'm to analyze it and then find out whether customers will churn or not. Yeah, predict it. That's what I was given. And the first thing I did during this project is that I have to create. I use Jupyter this thing for this. I use Jupyter ID. Yeah. The first thing was to make sure that this my data set is in the same position, the same location as the place where Jupyter files can be found. That means where I'm coding this thing now, this document is in the same place. So you see that there will be no conflict when I do this. So and the first thing, and after that, coming to the code, I have to import necessary libraries. In this case, I import pandas as PD. Pandas is used to handle different distinct, to handle the data, to put it into what we call the data frame. Yeah, that's why we use pandas. So actually there are many other libraries we import, but I want to do it step by step. This one is just like importing, just like it's more of like importing what you need, just for data. That's for loading data sets. That's for loading data sets. So if you go down, you see that after we have loaded it, we need to print out some things about it, the shape of it. That's to know how many columns and how many rows are there. And then we also have to find out what is that, like the information about the this in the data set, to tell us some things about it. When we run it, you see, I think it's already done. They will see how this work. So again, you see that we need to check whether there's missing value, because the question or the assignment requires that I also handle missing values. So let me run this particular one and see if I see how it is. Okay, it's coming. Okay, so scrolling down, you see the data set shape. It has 743 rows and 21 columns. Yeah, that's this now. This now. So if you check, it has 743 rows and 21 columns. So this is it. Okay, can see my cursor? So probably so moving down, you see that we have data types and null counts. Data types and null counts. You see there that there is a part of it that tells about what is contained in the data set. Yeah, we have all these columns. These are the columns we have, the name of the columns. From customer ID, gender, senior citizen, down to churn. The churn is what we're going to use as the target value when we get to that part. So you see that each of them has 743 rows. Yeah. So data type, they are all objects. Okay. So moving forward, we now check missing values. If there's a place that there's missing value per column, there's no missing value in this. I think everything is good. Moving forward to the next code. So the next thing we want to do is to convert some of those rows or columns to the point where they can be used for prediction, because machine learning, all this thing we are doing, it understands number more than using letters. Yeah. So you see that total charges is to be converted to numeric. You see. So and what we do, how do we do that? We use this particular code you are seeing here. Yeah. Sorry, this particular place now. My cursor is now moving around, and you see where that thing is blinking now. So this line of code is what we use. This line of code, that place where my cursor is, that's the line of code we use to do that. Then after that, after you must have done that, the next thing is to check for missing value again after conversion. After you converted that total charges, you check for missing value again to be sure that there's no missing value. So this code does that. Then next one, you impute missing numeric values with median. So anywhere that is missing value, we replace it with median. Yeah, for the total charges. If there is any at all, we replace it with the median of that particular column. That's the median number. Then if there were categorical missing values, we fill them with modes. The modes. Categorical means it's not actually a number. There are maybe letters, a kind of let's say states now. Let's say a particular state appear most often. So we use that state to replace any place that is what missing. So that's what we do here. So this particular part actually, this particular code down is here to handle majorly missing values. So let me run it so that you see the results. Okay, so you can see the result now. See, it's listed all those things inside categorical columns. The columns are categorical, and then data after encoding. So you see that this is what we have after we have encoded because we changed the total charges. And so there should be a new a new way to appear. And then some other ones remaining the same. So moving forward, you see that we have all the columns listed. All the columns listed. So now let's go to the next line of code. The next line of code is here now. It said we're going to import the train test split from SQL, that's scikit-learn.model selection. So we want to split the dataset we're given into training and test dataset, or train and test dataset. Before that is done, we normally separate what's the name, the targets. That's the result we hope to get, because in this case now we're using churn, right? So we'll then separate it from the main S value. This S value will contain what we call the futures. So the Y will contain the target value we are looking up to. So that's why we bring out that one just to be Y. Then every other thing apart from that churn becomes the X value. So we split, after we've done that, we split it into 80% training and then 20% testing using this particular line of code here. Then moving forward, we check the shape of each of the tasks we have done. Remember that we have train and test of X. Same way we have train and test of what, of Y. That was why it was good we did this thing we did here. So moving forward, we have we check the shape of each of them, both the train and the test. We check their shape. That's what you're seeing here now. We check their shape and this thing. So next thing is to check churn distribution in train versus test. That's one to check to make sure that they have the same, to make sure that they are actually normalized. You get, if they are not normalized, then we have to do what? Normalize them by using this normalizing. Normalizing is replacing the data there with the equivalent mean of 0 and then variance of 1. Yeah, there's a way the conversion is done. It is done in the code. So we run this code to see what would become of the code now. So waiting for the result to appear. It's taking time. Oh, sorry. There is. Okay, sorry, this is not supposed to be churn yes. There's nothing like churn yes in the code. I have to change it to churn, not churn yes. This is churn. What we have in that place is churn. That's a mistake. Let me check, maybe, let's check right to be sure. This is actually churn yes. Why is it not giving us? Okay, let's try churn first. Let's see if it works, but I think it should work. Okay, yeah, it's churn, not churn, yes. So this one you are seeing is when it has not been converted to this method. So that's why it wasn't working before. So when you check the result now, based on what I've explained earlier, you see that we now have the training set shape as this. Looking at it, they have the same number of columns. Yeah, the same number of columns, and it must correspond, else there will be a problem. If there's no the same number, if the columns are not the same, then it will not work. Then the churn distribution in training set, we have for no, we have this, and then for this one is for testing set. We have this standard distributions. I think they're almost the same thing. So that's when you have normalized it using that mean and this thing I mentioned earlier. So, and they must be of the same data type, float 64, float 64. So the next one, which is this one we're working on now, we want to know which features we are going to use. Yeah, we want to know the most important features we're going to use, and we'll be choosing around 15 of them, the 15 best features. Yeah, because there are actually 21 we know, but not all of them are important. Something like customer ID is just an identifier; it doesn't make sense. You get. So now, the thing is this: we are going to import libraries, which we need. Yeah, I think I have to re-import the libraries I've imported before. Not so important, but let me just remove this one. So we'll remove this. Even we don't even need the train again. I just have to, so we don't need them just for as explanation. They're already in the other one, the other code. So we are using this one, this code you are seeing here now. This code we are seeing now. So we have the three libraries imported: random forest classifier, matplotlib.py plot for plotting, and seaborn. We are using these three for all the things we are going to be doing now. Now we have to encode the categorical features automatically. Yeah, using this code. Next, we plot the correlation heat map for numerical features. Yeah, using this code here. So this particular code will do that plotting for us. And moving forward, we have the next thing, which is the next thing is to split the data set, which we have done earlier. We don't need to do it again. So the other thing we need to do is to use the feature importance. That will find which features are important using random forest classifier. So this particular code you are seeing here, that's what it does. This code now does that, this one. So then we have to save those features we have gotten so far. Those important ones, we take them as the important features. That's this line of code. We save them as the top features. Then we take up to 15 of it. Yeah, that's why I see here at 15, meaning we should take the first 15 out of the 21. We print them out and then see plots what we call their feature importance. Yeah, so what we'll do now is that we're going to run the code. If we run the code, you will have this result. So this is the result of, okay, I think we just have the correlation heat map now. Yeah, so this is the correlation heat map, and what does it tell you? This one is telling you, it's just trying to tell you how many times senior citizen were recognized as senior citizen, to tell you how accurate it is. And then tell you that's the red place now. The more tick place you have, those places show the more correlation it is. And the correlation of the tenure, you see that it's appearing on that red. Yeah, so the red has the more correlation. And that means if you check tenure, the tenure on the y-axis and the tenure on the x-axis correspond thickly on that red place. Okay, you can see that the other one has appeared. We have top 15 features. These are the top 15 features we're going to be using. And then this is the features being plotted. We have up to, I think, These are 15 of them. Let's count it. There, this is 3, this is 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the 15 features were plotted on this graph. So we'll be using these features in the course of our program. Okay, next, let me delete this. We don't need this here. Next, what we need is to now start using different models to do what? To analyze this. We have the logistic regression model, we have the linear regression model, many of them. So I tested different models, including XGBoost, random forest, and many other ones to be sure that what I'm doing, that I get the right one to use. Yeah, because each data set you are using has the model that will fit it very well compared to other ones. So in this case, I tested logistic regression, and you see the result of it, the training, everything got on fine. Then the next code I needed to kind of evaluate the things like accuracy, things like precision, F1 score, and I analyzed that this is the result of what I have from there. See the accuracy very high, 0.8, precision 0.65, and so on and so forth. So on average, we have 0.75 for precision, 0.72 for this thing for recall, and so on and so forth, as you can see there. Then we plotted the confusion matrix. The confusion matrix here. So you see how accurate it may be. And then we have the ROC curve for the logistic regression. This same thing was repeated for each of them. Remember that the ROC curve, in the ROC curve, the more closer it is to the y-axis, the better that model, the better it is for that model. Yeah. So we'll be using these features to analyze other ones. In this case now, we want to look at random forest. This is the random forest now. For this random forest, you see that we trained and it was saved. Then I think we also did the matrix. Yeah, the matrix to know how it is. So 0.78. You see that the other one was more accurate than this one. That's, I mean, the one we just checked. That's logistic regression model is better than the random forest. So you see, even the ROC curve, in the ROC curve, logistic regression is better. And we'll see compare everything at the end of the day so that we see it. So we have the decision tree model. So we tried it, save the model, and then still check the matrices, the matrix. And when we did that, this one is even lesser than the random forest. Okay, and you see, even the ROC curve is worse compared to the other two, so it can't be the best. Then moving forward, we also looked at XGBoost classifier. You see the model have been trained, everything is shown here, and then we check the metrics score, quite high compared to decision, but it's not as high as logistic regression. So other features shown here. And now okay, there's no ROC for this one, but it will be shown later on. We'll compare everything together. So the next thing, this code is actually meant to compare everything. So this code is to compare everything we have been doing. We'll compare the ROC curve, we'll compare the matrices to know which one is better, and then choose the best model for our work. So this is the ROC curve comparison model. So we see that logistic regression is the highest, and even have the highest AUC. That's even ROC. So 0.84. Yeah, AUC. That's area under the curve. Area under this curve now, that's the highest. And the other one has, other ones now are very, very less. They're not even compared to the other one, except the random forest that tried. Random forest and XGBoost, they tried actually, but this one making is out of the line. So we see that the best model for this is logistic regression. So that's the one we use in the code finally. So you see that I now have to use it here to get my final answer. But do not yet see comparing them. Yeah, in the comparison now you see that when put in table, you check. This one is comparing the accuracy, precision, and so on and so forth. You see that the logistic regression seems to be better. Not that it seems, but that's what it is. It's better compared to other ones. If you check the first values of it. Okay, I think yeah, better to see this. You see it. That's why we highlighted it here, because all of them, for everything, the logistic regression happens to be the best. So we have the next one now, which is to check the model performance. So if you see the model performance, you see that the the logistic regression happens to be the best among all of them. So it happens to be the first one is the logistic regression, and it happens to be the best among all of them when analyzed in their performance. So you see that it is the best. So that's the end of it. Thank you very much for your time, and I believe that you can also you have learned from what I just explained, and I thank the Saiket system for giving me this particular project. At least it has opened my eyes to a lot of things. I have been able to learn how to use different models to that's to compare different models and find out which one is the most suitable for a project. Yeah, so I'll be ending it here and believing that you can also use a code I added alongside with this to do the same thing I have done so far. Yeah, you can open it and then maybe through a notebook and copy it and use any ID you want to use it. Thank you.